It is 11:03 Mountain Time because I'm calling in from Denver today. So we're going to go ahead and get started. My name is Samantha Martin. I am the communications manager at Cleveland Water Alliance, and I am excited to welcome you to our August edition of our Water Data Forum. This month's theme is realizing interoperable water data across sectors. And we have a great panel lined up for you today. Just some logistics here. We welcome questions. We have time at the end to get to any questions that you have. So please submit questions through the Q&A function. You're also welcome to submit through the chat. We'll be monitoring that throughout the discussion, and we'll make sure we'll save time at the end to address questions. This webinar is being recorded, and we will send the link out to all registrants so you can view it later or share. So I am excited to announce and introduce our moderator, Anthony Oftenkamp, the Senior Environmental Scientist at Limnotech. He will be navigating this discussion and introducing our panelists. So take it away, Anthony.
Thanks, Samantha. Your slides aren't advancing, however. We're just seeing.
Thanks for the notice. I'll go ahead and I'll close that out and pull it right back up.
All right.
Webinar without some technical difficulties. Right?
Well, thank you so much for organizing this, and thank you all participants for attending. I'm Anthony Oftenkamp, Senior Environmental Scientist at Limnotech, where I've been for nearly 5 years after 14 years in academia at the Stroud Water Research Center, where I got connected to all of the other panelists. So I'm really excited to have been asked by Cleveland Water Alliance to moderate this session. I will introduce each of the panelists, and if you want, Samantha, I can take over the screen sharing. All right, I will do that in 1 second. All right. You should be seeing the list of all the other panelists now. Tony Castronova is a hydrological scientist and environmental data science at the Consortium of Universities for the Advancement of Hydrological Sciences Incorporated, or otherwise known as QuasiHist, an academic organization funded by the National Science Foundation with the explicit purpose of bringing together water data, among other mission statements. Peter Callahan is the executive director of the Internet of Water project at Duke University. John Dawes is the founder and executive director of Chesapeake Commons. And Dwayne Young is the chief of water data in the integration branch at EPA's Office of Water. And each of them will introduce a little bit of their work as they talk in the next few moments. I don't know, Samantha, if you wanted to kind of acknowledge the contributors and founders of the Water Data Forum at all.
Yeah, thanks. So this Water Data Forum is a monthly series presented in partnership with Cleveland Water Alliance, the Midwest Big Data Hub, and the Water Environment Federation. So we're bringing you a new topic, a new set of speakers every month, and stay tuned. All registrants will receive information for September's forum. So go ahead and take it away, Anthony.
All right, thanks. I'm going to reveal my jumbled screen here. And really answer kind of the first question, right? The title of this presentation is Realizing Interoperable Water Data Across Sectors. So the question is, what is interoperable water data? And it kind of came out of, in many ways, a dialogue that came out of two events that happened more than a decade ago. There was an executive order from the White House, and I think around 210 for all government agencies to open up data. And that really got all agencies, including the National Science Foundation, and then our agencies that oversee our water data, really thinking very seriously about how to fulfill that mission. And then the other one is that about 15 years ago, there was a freak a massive electrical power outage all across the eastern United States due to one little hiccup at a power station in Ohio. And there was this realization that our electrical grid was not really very smart. Like the wires were connected, everything depended on everything else within these regional grids. And yet there was no exchange of information that would allow the electrical utilities to actually manage the flow of electricity. And very shortly after that, people started saying, huh, the same kind of applies for our water data. I think the concepts and vision of what interoperable water data can do are kind of best summarized by the initial reports from the Internet of Water project, and Peter will be talking more about that in a little bit. And what they elucidated and kind of described as this kind of national movement to open up governmental data that I described was unfolding in the environmental sciences and other sciences, were that interoperable water data is just one part of kind of the open data equation. If you want to have the benefits of a smart electrical grid or a smart water utility, or more ambitiously, a smart watershed management, there are many steps to having that open data be usable. The first one is that you need to be able to find the open data. And then once you can find it, then you need to be able to search it in the ways that we search things on, the modern internet. We all know how powerful search can be. And yet it was quite frustrating at how little we could do at finding data. But once you find it, you need to be able to access it. In other words, download it or potentially automatically start using the data and looking at the data or visualizing the data. But for those next steps to happen, the data actually has to be interoperable, which is what the topic of this is all about. And interoperable data is one step beyond actually being able to get it, but it's being able to get it in a way that it works with other data that should be similar. And this means a lot of things, this interoperability. A lot of it's technical, but some of it's not. Some of it is simple as spelling the word. If you care about water quality and phosphate or phosphorus in your water, then you need to be able to spell it the same way. Is it phosphate? Is it SRP? Is it orthophosphate? Is it total phosphorus? And how are those different? And so there are ways to do that with controlled vocabularies. There are also ways to have keys and indices and codes that are interoperable and reusable. So we all are familiar with USGS site IDs and how useful that can be, but how does that connect to other things? So there's a lot more to interoperable. And then the final step is reusable, which we're going to talk a little bit less about, but it's implied. Is there enough information about the data or metadata with that data that's included, that comes along for the ride, so that the end user can actually trust it enough to use it again? And that's a really important part of it. I will end to say, wrap up this little segment to just say that this isn't actually a completely new idea. The whole internet, the web, and smart data systems are built kind of on these triangles of interoperability between the catalog, i.e. Google, knowing all there is to know about all the web servers and data servers that are out there, and the web browser knowing enough to start the search with the Google catalog, and then the Google catalog says, your answer is over at this other source of data, and then the data being delivered so that it can be read by the web browser, right? So, this is the case for the modern internet, and really should also be the case for the Internet of Water and what we mean by interoperability. There are more aspects to it beyond metadata. An information model that is shared is really important. The web has an information model. Water does too, as it turns out. And there are several information models out there, and we might talk more about that, such as the Open Geospatial Consortium's observations and measurements data model. Those things are incredibly important for interoperability also. So with that, I'm going to end my screen sharing. Whoops, need to stop there. And we are open for questions. You can type questions into the Q&A chat anytime, and we will respond to them at the end or maybe in real time. So go ahead and do that. So why is interoperable water data useful? What is the value of interoperable water data? And I'm going to pitch this question first to me and then hand it off to John Dawes. So in my current position at Limnotech, a water resources firm that has a very high diversity of clients, we're always trying to provide the most value that we can, bring the most information to the table that we can to solve any problem or any challenge that any of our clients are facing. And you always want to start with information. There's so much conversation about data-driven decision-making or data-informed decision-making if there's, some non-automated steps in the middle. And yet getting that data is exceptionally hard. When we do a watershed model for an agency or a municipality, we charge a lot of money for that effort because it is unbelievably challenging and time consuming to fetch all the data that goes into parameterizing and calibrating a model, driving that model with climate data from all these diverse sources, this alphabet soup of agencies and data sources and data programs, presently takes a lot of work. And we will spend 80–90% of a very significant budget, a three-figure budget to model a watershed. 80–90% of that is on data harvesting. Imagine the value we could give to our clients, to the water resources management community, if getting that data fully into our models was 10% of our budget, or the 10% of our current budget. So then we'd be able to do things for cheaper. We'd be able to model more watersheds. We'd be able to provide more informed decision-making. And potentially we'd be able to take the next steps that we all want to take about really having honest to goodness data-driven or data-informed decision-making with decision support tools that are real-time, or at least operate in real-time, providing answers for different scenarios in the real time of the decision-making process, which is complicated. And that's not how we do things right now, unfortunately. John, what is the value in your community for interoperable data?
Yeah, thanks, Anthony. So, I will just quickly just give a brief background. So on the commons front, we focus specifically on environmental software development. And our work has been primarily focused in supporting community science organizations with structuring their water quality monitoring data. But then we also work with a lot of larger scale nonprofits that, such as National Fish and Wildlife Foundation, that really want to quantify the benefits of best management practice implementation in a given watershed. And so one of the big values of interoperable water data for us is to be able to tell that story of how actions on the landscape actually impact water quality. And, I think you hit the nail right on the head in that most of the data that is in existence today requires a ton of, massaging, reconciliation of schemas, to be able to tell that story. And I would say also that where we sort of lag behind on the water data infrastructure side is that we don't really have established, we're laying the framework for it, but we don't have an established pipeline that can accept real or near real-time data to be able to tell that story. And I would, break that technical explanation into some simple terms, like the services that we use on a daily basis, such as weather.com or Weather Underground, as well as even things such as different forecasting applications in Google Maps that can give you real-time, ETA to your destination. We should be able to emulate those same models in the 21st century with how our watershed is responding to actions in the landscape. So as far as building sort of that pipeline of interoperable data, that's one very big valuable component that would enable us to really start lowering the overhead and costs of modeling and sort of telling that story of how our actions are impacting water quality. And the last thing that I'll just add to that quickly is that, best management practices is one example of many. So there are obviously implications to compliance and enforcement with, wastewater permits, et cetera. So I'm really trying to build up those information pipelines to send data for interpretation quicker is one of the big key components of making interoperable water data a very valued piece of the puzzle.
Thank you. So we have a need and we have a vision, which we're going to get to at the end. Let's kind of pivot to what's the current status of interoperable water data infrastructure, the Internet of Water vision in the United States. And we're going to start with kind of looking at the federal perspective from Dwayne, and then move to Tony to describe how Quasi is trying to aggregate all the smaller entities, the non-federal entities, or at least as many as are willing and interested. And then move to Peter a little bit to kind of wrap that up at kind of a community level before we then wrap this up, this panel discussion up with talking about the vision of where we want to go and how we're going to get there. So Dwayne, what's the current status of federal water data infrastructure and its interoperability and reusability?
Yeah, let me take a crack at that, and I'm glad I've got a couple of good follow-up batters behind me that can help bring it home. So let me share my screen. All right, do you see my screen?
We do.
All right, excellent. So I wanted to start with this slide just to get this idea that this is something that's been worked on for a long time. So for anybody who's been around for a long time, you look at that, and I would be really impressed if people could pick out that this is what you're actually seeing here on the screen is Reach File 1. So RF1, which goes way back in some of the early days of thinking about how we connect water information together. So I was able to find this online. It was not easy to find and pop it into a map. But this kind of starts as what we see from the federal sector as the first of the frameworks and the frameworks that we build on top of. So I'm going to talk about all the pieces that are out there that go into water data interoperability and kind of give my sense as to where they're at in terms of maturity and some of the opportunities as well for improvement. So first of all is the hydrographic frameworks themselves. So, you see RF1 here on the screen. That's been replaced by the National Hydrography data set that's managed by the USGS, which has been a constantly evolving and improving product over the past several decades. And they really are sitting on the edge of taking an evolutionary leap in regards to mapping capability. And the reason why you start with these frameworks is because in order for water data to really be interoperable and discoverable, it needs to be connected to a common framework. It needs to be connected to the landscape. It needs to be connected to the water itself so that you can discover information using upstream, downstream, within a watershed type searches. So the two frameworks typically that we talk about are the National Hydrography Dataset and the National Wetland Inventory that's managed by the U.S. Fish and Wildlife Service, who's also looking at an evolutionary leap forward in terms of capability with their resolution and data that they have. And also, they're also looking at how can they better connect those two frameworks together. So those are some exciting things that I think we will see in the future. The next big piece is models. And Anthony, I think, did a great job talking about the use of models and why models are important. Models are a big part of everything that we do. They are a big consumer of data too, but there's also, I do want to point out, there's opportunity for interoperability questions on the model side as well. We have national level models like the National Water Model that's run by the National Weather Service that is predicting flow at every single NHD plus, again, going back to those frameworks, NHD plus reach, which is just an incredible leap to be able to do that. And they're looking to improve that as well. Regional models and then local models as well. And so being able to think about how those models need data and consume data, and also opportunities for them to be interoperable with one another. So next thing is data. So on the data side, from the federal perspective, I think we've made a lot of efforts in trying to standardize our data, at least with the first one there, the idea of standardizing around measurements and observations. So measurements and observation, there's been a lot of work to try to standardize that. Open Geospatial Consortium has developed standards around that and identified ways to collect that information. But there's other kinds of data too that we really need to be thinking about. There's activities that are on the ground. John talked about best management practices or other activities. We need standard ways to be able to communicate those. Events that happen. These could be spills, they could be harmful algal blooms, other things that happen that we need to be able to communicate in real time. Those need their own set way to be able to describe them. Assessments and conclusions. People make decisions about water all the time, about whether or not there's enough water, what the water quality is, based on the legal context, which is that last one. So we need standard ways to be able to describe those assessments and conclusions. Then legal context, the last one that I identified there, these could be things like water rights out west, where states define how much water can be used or withdrawn from a given location. Or they could be water quality standards from my neck of the woods. So the idea of what are the water quality standards to provide context for all of the other data that stands above it. Data standards are really critical for data interoperability. And I would say also there's been a lot of work in this space as well. Open Geospatial Consortium is an excellent source of data standards. They put out a number of data standards that really can help move things forward in the water sector, the Sensor Observation Service, WaterML2. And then there's a relatively new one called Sensor Things API, where we see a lot of opportunity for being able to help standardize around some of those measurements, observations, especially the time series or the real-time data. There are also mapping standards as well, again, coming out of the Open Geospatial Consortium. And if you start talking about data interoperability and being able to reuse other people's data, talk to a GIS person. They've been doing this for decades. And there's a lot, and that's all done very easily and nicely because of these data standards, the web map service, the web feature service, there's a lot of capability there. And then there are also domain specific standards that have been around for some time. The WQX or Water Quality Exchange data standard has been around since about 2005, 2006. And that has really gone a long ways in standardizing water quality sampling data and has enabled for pretty broad sharing of that class of data, but there's a lot of opportunities for other classes of data to be standardized as well. And then a couple other last pieces, which I think are critical for data interoperability and where things stand. So on the catalogs and discoverability, like how discoverable are data, there's different tiers of this. So there's registered data sets with metadata. So these are places where people have a data set, they register it in some site so that, and then those data are discoverable on those sites. HydroShare, which the Quasi folks developed, is an excellent example of this. There's also collated data sets with metadata. So this is where you take data and you compile it all together. You standardize all the data so it's all in the same format. Makes it easy to be able to download data from multiple different people, and you don't have to do a lot of reformatting of the data. Water Quality Portal is a great example of this, and also is Quasi's HIS system as well. Then there's some new things that are under development that are worthwhile keeping an eye on. The National Hydrographic Infrastructure, which is something that USGS is leading, which is really trying to standardize how you connect information to those hydrographic frameworks. So they're looking to standardize all of that. And then there's some efforts being led by the Duke team at the Internet of Water team in partnership with USGS, their Geoconnects project, which again is looking to try to make data more discoverable through Google web searches. And they're looking to enable that so it's a much more automated way. And kind of the last thing, this is probably the predominance of the data that's out there, is there's a lot of uncatalogued data out there, but that is still searchable though. So you can find it, you do a Google search, you find the data, but it's in who knows what format, and you have to spend that 80 to 90% of the time that Anthony mentioned earlier to try to reformat that data and make it usable in your systems. And then the last, but certainly not least piece is the common terminology, the common terms, making sure that we're using the same kinds of terms as we talk about different things. There are a couple of items out there where there has been attempts to try to standardize at least some of the terms that are used for the measurements and observations. EPA has a substance registry system, which identifies a standard term and then cross terms for all of the substances that can be monitored for. And then there's a similar system, the COMPOC system also coming out of EPA that does look to also identify some of those standards. And And then the last piece that I'll just talk about, and I'll be really brief on this, is just really focusing, there is the data part, right? Which that's what I just talked about. Then there's the people part that's really critical, and it's how we go about doing this. And there is a reason why we've been talking about data standardization for the last 20 years, and that's because this is not an easy thing to do. But what is exciting from my perspective is that there's a lot more people that are talking about it, and there's a lot of leadership that's happening at very different levels. This is not something that just the feds are going to do or the states are going to do. It's something that's going to take cross collaboration and across to everybody from federal, state, academia, community, municipalities, businesses, et cetera. There's a lot of effort that's going to need to go into this, and it's going to take a lot of coordination. I did mention some of the improvements for the underlying frameworks are planned and are coming soon. Standardizing methods are being designed for connecting to that common hydrography, so that national hydrography infrastructure that I mentioned. There are data standards that are starting to emerge, but we're not seeing a lot of adoption. So that Sensor Things API, it's new, not broadly adopted yet. The Sensor Observation Service has been around for a little bit longer, also not broadly adopted. So those are things that I think are worth keeping an eye on and trying to encourage to move forward. And then there is always the risk of a million flowers blooming. Anytime somebody comes to this situation, I've been doing this for 20 years, every time somebody comes in, they immediately say, well, we need a standard for that. So then they develop a new standard, not realizing there might have already been a standard out there. So y'all know that long thing. So really just encourage people to be careful not to reinvent the wheel, spend some time to try to figure out what else might already be out there that you can reuse. There is, especially I think this is a United States situation, we really don't like using something that somebody else built. And so really trying to avoid the not invented here syndrome, the idea that, well, because I didn't do it, it's not any good. So it is really important that we think about how we reuse technology and standards, et cetera. And there will likely be overlap and conflicts. That's okay. That's just part of the process. Let's let it play out. And then the last piece that I'll say, and we see this a lot, and I know John's got a lot of experience, maybe Peter can speak a little bit more to this too, is we see a lot of variation in technical capability as well. Different federal entities have different technical capability to be able to publish their data versus states, versus tribes, versus local communities. And so keeping that variation in technical capability in mind, not everybody's going to be able to just stand up a web service and API out of the bat. So we have to be thinking about how do we build tools to bring the technology to the groups that have the data and are needing to publish the data. And so with that, I think maybe I'll turn it over to Tony to talk about Quasi and some of your perspectives.
Great. Thanks, Dwayne. That was a very thorough overview, and I think that's going to make my life a little bit easier. So I'll be relatively brief here. A couple of things I'm going to talk about are directed at how Quasi as an organization is providing data publication capabilities to mainly the academic community, but also bridging the academic community with some of the data sets that Dwayne just talked about. So the one system that's been around actually for quite a while, I think it goes back a little over 15 years, is something that Quasi was fortunate to be involved with. It started as an NSF proposal, and this was the Hydrologic Information System, which has been mentioned earlier. And Anthony actually showed a figure of the internet, right, of the catalog, the clients, and all the distributed data. And that's essentially the design of the Hydrologic Information System. But in this case, we have databases that are hosted by individuals or labs or institutions, are hosted on, throughout the world. And they're all connected together using a central catalog that Quasi maintains. And this is all done using standards for how we communicate between these distributed servers, standards for the language we use. We've seen that already with controlled vocabularies, the standards for how we encapsulate the data and send it over the web so that when we write code or develop other applications, we know how to interpret the data we're getting. So, I mean, obviously standards play a huge, huge role here. Unfortunately, there's no one size fits all standard. So we end up with this, everybody wants to create their own standard situation. But from my perspective, I think as long as we're clear about how our data is represented, that's really the essential point for interoperability. So if we choose to use different methods for encapsulating our data, that's fine as long as we're very clear about what we're doing and how it should be interpreted. So that's one of the things I want to touch on with the QuasiHist system. The way that this is actually progressing in the future, it's been around, like I said, for over 15 years now. I think we're going through a modernization process where we're redesigning a lot of the underpinning software that keeps it all together. And we've seen over the past number of years that a lot of individual scientists or researchers or small organizations don't actually want to hold on to their data and maintain those servers, which is completely fine. And Quasi has been kind of gradually hosting these on our own. But the ability for an individual field scientist, for instance, to go out and collect data and publish it in a way that is discoverable right alongside the USGS data or the EPA data or whatever is really powerful for advancing science. And that's kind of where our focus is. So the other thing I wanted to mention is this HydroShare application. So like Dwayne mentioned, this HIS is very structured. I think you call it collated data. The HydroShare is where we call it just a data repository. You get a web page, you upload your data, and you augment it with, or you add metadata to it, and then we say, okay, this is some rich content. We call it a resource, and we can even publish them and link them in scientific journal articles and stuff. And again, the reasoning for this is Quasi interfaces quite closely with the academic community. And this is another NSF project that we were part of. It's actually still ongoing. But one thing we've noticed with this HydroShare platform is that this is what we call a domain-specific repository. If we know the type of data that's coming into it, we can provide additional features, right? Because we know what type of data it's supposed to be, whether it's time series or not. We see more and more of these popping up around the community, right? So there's a few that are, one that we're pretty close with is EarthChem. I was actually recently on a part discussing with some people about creating a new repository for their community's data. And the thing is that, we don't want to have what Dwayne said, like everybody reinventing the wheel. Instead, we actually are quasi shifting focus to provide interoperability at the organizational level between these different data repositories. And it's a very challenging thing. And I think Peter might discuss more about that. One of the projects we're looking at to kind of push this work forward is looking at the critical zone observatories and that network. That data may fit in multiple repositories. What's the right one? Well, one thing that we can do as an organization is help guide the scientists to figure out where their data should exist, and also follow standards to expose the data, make it more findable across multiple repositories. One way we do that is by adopting software standards and schemas that will interface with Google. So Google dataset search, why reinvent a search interface if Google's already doing it? And like I said, I was gonna be a little brief, but the one last thing I want to mention that what was touched on earlier is that there are another thing that we're quasi struggling with or challenged with right now, or trying to work with the community to solve, is what do we do with these large model data sets that are appearing? Turns out it's actually kind of easy to create a lot of model simulation data, and it's not really clear where that data should go or how it interoperates. Sometimes we have data sets that are just value added. If you took the NHD river network and you made some corrections to it, where do you put that? And how do you reference that back to the original data set? And how do you make that accessible and interoperable with everybody else? These are very challenging problems that are popping up, and we see more and more data sets such as National Water Model and other large data sets appearing in the commercial cloud like Amazon and Google. The community is starting to adopt cloud optimized data formats, and it's really exciting. But how these large data sets, oftentimes gridded and multi-dimensional through time, how do they associate with the hydrography or some observations that we might have in other repositories or networks? That's still a work in progress. I think it's a really challenging problem. And I think I'll just leave it with that. So Peter?
Yeah, thanks, Dwayne and Tony. Perfect setup for me. I actually have very little to add. Those of you who've been involved in this community know that the foundation of federal data that Dwayne described, and then the enormous work of Quasi over the years to bring the scientific and technical community effectively together, which is really a cat herding serious cat herding exercise, but vital to get kind of a common approach going. And then what I'll say that we in the Internet of Water project are trying to the kind of category we're trying to reach to, in addition to kind of linking to Quasi and feds, is really the states and local holders of data and local governments. So the states are enormous repositories of water data. Many of them have a sovereign responsibility to control that data that's outside of the realm of the federal responsibility. And a lot of the states, they vary wildly in their capacity to manage that data. And so there's a number of initiatives underway. Some legislation has been passed in California and New Mexico, the open water data legislation in California, the New Mexico Water Data Act. And in Texas, there's some underlying percolating activity, the Texas Water Data Initiative coming online. And also in North Carolina, we've been working with the state to, particularly on a certain set of drought and water supply data sets to try to improve interoperability, accessibility there. So really kind of helping the states is a key aspect of what we have to do, and local communities, and doing so in a way that connects to the feds and to the scientific community. Like, so in a way, the Internet of Water concept has to kind of become something that everybody is participating in, and everybody kind of agrees on, and in a way that is essentially through standards, through rules of the road, through common approaches to doing this work. And so that's all I'll add right now. I'll say the states, some of the states sort of keep their water data like in the trunks of their car, right? It's sort of that inaccessible, and others, make it really possible for you to get it. So I think we really want to work together as a community, and I'll say a little bit more about the future, kind of how we might all bring it all together in a minute or two. So
yeah, thank you, Dwayne, Tony, and Peter, for talking about the current state of water data interoperability. And we're going to now kind of think about the vision, like what could be possible. Clearly, there's been a lot of work done. There's a lot of interoperable water data already in place, especially from federal agencies. So what could happen in the near future by taking advantage of what currently exists? So much of it is new. A lot of people aren't taking advantage of what exists. And what are the things that kind of the few next steps that are needed to get us to the vision, and what is that vision? So back to you, Peter, and then John will wrap up. And then I see that we have 2 questions in our Q&A, which we will answer live in the final 10 to 15 minutes.
Actually, John, I was going to see if you wanted to go first, and then I'll show my groovy little video.
Awesome. Yeah, well, thanks, Peter. Yeah, happy to be put on the spot there. I'll say, I think this does kind of piggyback on the last question, which is, form really does follow function in a lot of this. I think being sort of trying to be the optimistic software developer in a lot of this work, I'd say that we're sort of on the Renaissance trajectory in terms of a lot of really exciting new applications being able to be built on top of this infrastructure. I'll also say that, in our experience working with many groups, there has been so much focus on the structuring and interoperability of data, but thinking about, what specific use cases, what systems do we need structured water data for? I'll say that in a lot of our work that we do at the Commons, we're focused primarily on an R&D project now, and I can share my screen quickly just to give kind of a quick example of what we've been up to. We're actually working with the Google Home and Google's natural language processing software, which is essentially an AI framework that converts human narrated speech into a set of tasks and fulfillment requests that a computer can essentially execute on. And so one of the pieces that we're looking at here is being able to start pulling data from a variety of different indexes online and then start to organize that content in a way that it could answer a series of fulfillment requests. So what we're looking at now with some of our water reporter data that's structured through our developer API and also third-party services such as SwimGuide, we could use the NLU and Google's Dialogflow to essentially ask and answer different questions. So we're starting first with really simple questions, right? Like, what watershed am I in? What is the nearest monitoring location near me? And in that sense, we're able to leverage a lot of these available services that are online, such as the NHD for catchments to identify watershed boundaries. And then down the road, as we start to understand a lot of the structuring around specific parameters and how they're used, we could answer more sophisticated questions like, is it safe to swim near me? Or what is the E. coli concentration at a station near me, et cetera. And all of this is to say that, yes, this is kind of some hokey R&D work, which I'll be the first to admit. But what I'd like to convey with this type of a project is that because we're sort of at the beginning stages of building apps and software on top of this data infrastructure, there's a lot of need to make these data pervasive in people's everyday lives. And much like the weather service and systems like Google Maps that we use on a daily basis, it's going to take a lot of trial and error and more or less tinkering to kind of build these infrastructures and align on what those specific workflows are. So in terms of the future of water data and what we can expect, I think I hate to pun on the question, but it is like sort of to be determined, right? Like there's going to be, I think, a pretty large boom in applications, and with this water data infrastructure, I think there's a lot of room for innovation where a lot of different software development companies can start to commercialize and build specific apps that support everyday workflows. So this is one example that I wanted to share with you all in terms of the future, but I think there are many, many others, and sort of excited to see where a lot of that goes.
Thanks, John. And I'll just say, I'm going to say a picture's worth 1,000 words. So I think to support all that's been said, and particularly to support the last thing John said, to come to that place where we can ask Alexa for information about the river we'd like to go visit today, it needs to be supported by the national infrastructure that Dwayne described earlier and the infrastructures that Tony described. All of that has to sort of be brought together in some way. And connected. And so we think that the National Hydrography Data Set, the evolution of that to the 3D hydrography program of the United States Geological Survey, is kind of the home base for this discussion. And we're working with the Geological Survey to create this concept called Geoconnects, which Dwayne mentioned, which allows for the persistent identification of water data on the internet persistently everywhere, metadata pages for basically all water data. So what does that really kind of look like? It sort of looks, so we have a nice visual that was created for us by a wonderful guy named Sam Lerner. I'm going to share the screen, see if you guys can see this. This is maybe a little bit what the future might feel like, where we can experience water data in 3 dimensions as part of our natural environment, wherever we are in the system, we can get the water data. So as we're coming along the Animas River here, I'm going to stop the movie, and then these are points of diversion. The red sites are where the Water Data Exchange of the Western States Water Council records points of diversion. The yellow sites are where EPA's Water Quality Portal has data about water quality. The green sites are USGS stream gauge. There's no chart there, so I'll see if I can find, go a little further down the stream and see if I can find a better stream gauge one. No data there too.
I think we're having some trouble seeing your screen right now. If you want to go ahead and stop the share and restart, and we'll give that a try again, because I know it worked earlier.
Okay, great. Sorry. Let's see. Okay.
There we go.
You guys see it now? Okay, great. So we'll back it up. So this is essentially,
There
imagine this future where you can picture the water in 3 dimensions or 3-dimensional topography, water presented where you live and connected to what you know. And so here, what we're showing is the water data linked to the National Link Data Index and visualized. Again, these are the red spots that show points of diversion that are held by WADE. Yellow indicates where there's water quality information from the water quality portal. Green in this presentation are USGS stream gauges. So the notion is that you should be able to interact with this data and search and find, both as humans, but also as machines. Machines need to be able to find this information by geography. And so I think the future is really about the geospatial representation of water data, which is challenging for both geospatial people and water data people. Dwayne actually gave me a nice phrase that I reuse all the time now, which is the water data folks world has to put their geospatial eyeglasses on, and the geospatial folks have to put water data eyeglasses on in order to make this work, because it's not there's not an exact transfer. But if we can do it, then we have this sort of beautiful new frontier that we can all live in, where these data sets can be integrated, associated with specific geography. We can add groundwater, and then John can ask Alexa about the river nearby. So that's what we hope is the future.
Thank you for all of that. It's been great listening to all the panelists, and now it's time for us to listen to the attendees. We've got 5 questions that are open in the chat, and I'll read them off and pitch them. We should try to answer each in about a minute or so. Bob Heath writes, will the recently passed infrastructure bill devote funds toward water interoperability? What are the major shovel-ready projects toward that end? I don't know if Dwayne or Peter have tuned into that.
Dwayne, maybe I'll let you answer. I can answer if you like.
Yeah, I'll take a crack at it, Peter. Let me know if I missed anything. So, as a lot of you know, it's a 2,700 page bill. So sometimes finding these things is not easy, but there actually is one item in there that is a water data pilot program. If you're interested, it's section 50213. And it's targeted at providing grants to states and communities and regional consortium that have specific water quality issues. And it provides, it's a $15 million a year grant program that is intended to be able to build water data interoperability. And it's a pilot program to see how it works. So really, really excited about things turn out in the final legislation, but it's something we're really looking forward to.
And we were, of course, thrilled that the bill actually references following Internet of Water principles, which really, in my mind, forces the question in a way that's very helpful, because folks don't really know. Most people don't really know this language that we are all speaking, and it's important that this language become more common across states and local governments. And so having the legislation, having the money, and being able to say, these are the principles you need to follow, and oh, by the way, we're here to help you figure that out. The whole network of the Internet of Water, which includes Quasi, WADE, everybody that is a Water Data Collaborative, it's a really important step forward from my perspective. We're totally thrilled about it. So, and there are shovel-ready projects. I think there's plenty of states that are ready to go, trying to. All they need is a push. They need their. What we learn is that it's mostly a human problem, a leadership issue, prioritizing this in state budgets and stuff. So,
yeah. Thank you. Mark App asks, are the current standards, in quote, too cumbersome? I have seen projects crushed by trying to follow unnecessarily complex standards. I'm going to pitch that one to John first, and then maybe Tony could add to that.
Great. Yeah, so I think it's a really great question to bring up. Again, speaking from the perspective of community science groups that we've tried to work with and help along the way. There can be some real challenges, and I would say cost and overhead in adopting these formalized standards. I think that I would actually say that they're not burdensome from the standpoint of with these standards, most of these groups can actually pull out subsets. And one of the things that we're looking at with some of our software is essentially how to adopt a common standard and then make it easy for that user to break off small pieces of that standard. So with one example, like following essentially a schema such as water quality exchange, right? It can look very intimidating at first. However, one of the components that can be addressed through different software development approaches is, again, carving off small pieces of that WQX standard and sort of mapping those pieces to what a monitoring program is implementing. And by doing that, taking the time to kind of invest in those resources, you're positioning your program to be automatically incorporated into a federal decision-making system. And I think that that is something that the long-term benefit of that for inclusion in federal decision-making and also greater movements and initiatives such as Internet of Water really outweighs sort of the short-term overhead in kind of getting that set up.
Yeah, so I'll add a little bit to what John said, but I completely agree. From my perspective as a hydrologist in hydroinformatics, the standards are cumbersome and they're challenging to implement. But working with computer scientists and software engineers, it's really nothing new for many of them. Standards exist in all different fields. And I guess I just want to emphasize what John said is that I completely agree with this, and that the benefits, the long-term benefits outweigh the challenges, the costs of adopting the standards greatly. One of the challenges that we've seen and is if you have people contributing data to a system that uses standards, they need to adopt some standards or language or structure their data a little bit differently. That can certainly be challenging. Probably shouldn't be overlooked, but I mean, that's nothing more than documentation, maybe some tools to help them. Having your data system in general pluggable with these other systems, or interoperable, I guess, with these other systems, far outweighs the cost of trying to implement it, even if that means hiring some software engineers to help out.
Yeah, so what I hear is that the burden is on the software engineers collaborating with the hydroinformaticists rather than on the end users or the contributors of the data, right? It's the systems that are required that enable the interoperability, and that's where the heavy lifting has to happen. And in my experience, unfortunately, environmental data are complex enough that typically if you just take a data scientist trained in data science in general, put them on the task, they fail. It basically requires a collaboration. Environmental data science is its own field of study that is special and different than the data scientists that Google typically hires, right? So, and fortunately, we have those teams that are emerging. Unfortunately, the resources that have been applied to this historically have been pretty thin compared to the resources that are available to the big tech firms. This is a quick question that I hope John can answer from Sudhir Kishagar. Question for John: what knowledge management framework are you using to store the metadata in your Hey Google app?
Yeah, so great question. So right now, we're actually using Google's cloud storage. It's basically, if you look at the Google Cloud platform, there are a handful of database storage solutions. So we're relying on a couple of them for the natural language processing. And then really what's pretty unique about the approach that we're taking is a lot of these services are getting called on the fly, which is pretty exciting. So, what we're experimenting with now is we're first hitting our internal APIs for Water Reporter to pull back station information. In the coming months, we're going to try and leverage other public APIs, such as the Swim Guide API. So essentially all of those calls will be made on the fly. And then what we'll be doing is through Google's cloud platform, start storing sort of like the common follow-up requests and intents so that our system can kind of learn what a well-answered question looks like or a poorly answered question. But I'd be happy to follow up and send links to our stack and what we're using in the chat.
Thank you. Mary Eggert asks, sounds very promising, guys. Thanks. Just curious, how are we bringing the water usage data from utility to the consumer end use? Meters currently go to the home, so we miss the actual consumer usage data outdoor versus indoor, and the data on energy loss within the water, energy loss along with water loss. I don't actually know who to pitch that one to. Is anyone familiar with smart water metering within a home or within? I might take that. So smart water use and smart water tech is actually one of the booming Internet of Things spheres. It's actually very different than what we're talking about here. It's very industrial scale water use. It's a very simple set of measurements. It doesn't use environmental data science. It just uses straight up in data science. It just uses straight up IoT, not environmental IoT, which is a little different world. But companies that do things like irrigation services or that are using water within their factories, or even water utilities that are distributing water through their network are definitely entering the era of smart water. I know this from conferences and other conversations that I've been involved with, both public and private. And I think it's only a matter of time before the smart water usage information that's being collected at kind of industrial utility, municipal scales trickles down to the consumer. We are just now beginning to have smart thermostats and smart electrical meters in our homes. It won't be too long before we're starting to monitor the water flow rates, to different portions of our house. But I do think electricity will happen first. That's the last question. There was another one that had come and gone, so I don't know if it was retracted.
I typed the answer in. So just a technical question about Geoconnects.
Oh, right.
So we are right at time. Great timing, everyone. Thank you to all of our panelists for this really engaging and exciting content. And thank you to everyone who tuned in. Thank you for your great questions. And thank you especially to Anthony for your superb facilitation skills. There's so many pieces of this conversation that are ongoing. And we look forward to continuing the conversation in next month's Water Data Forum. The date is still being set, but it will be at the end of September. So you will receive more information about that, and you will receive this recording. So feel free to send it to any colleagues who couldn't tune in. Thank you all once again. Thanks for your time. Thanks for your interest, and we hope you have a great day.
Thanks all.
Well.